So we're at the end of chapter 3 now, section 3.7, finding domains and ranges from graphs. So we talked about linear functions in the last section, and we talked about domains and ranges. Domain is the x's, the inputs, range is the y's, the outputs. So there's really only one thing we want to do here, and that's find domain and range from a graph. So just a little reminder, the domain of a function or equation is the input set, the set of all x components of the ordered pairs. We can think of this as the set of values on the x-axis that the graph covers. That's how we determine what the domain is. For range, for a function or equation, it's the output set, or the set of all the y components of their ordered pairs. And so we can think of this as the set of values on the y-axis that the graph covers. So same idea for both of these. We're looking at the graph itself and how many values it covers from its smallest to its biggest. So we have 4 examples to get you going on this. So on this first one, if we're looking for the domain, this is the start of the axis. It starts at this point, -3, and it ends at this point. So this value here, from there to there, is our domain. So the domain would be an interval, it's a set, from -3 to 5, inclusively, because it had filled in circles. The range starts here and ends here. And our range is all of those y values here. So the range starts at -2 and goes all the way up to 4. Again, both of those points are filled in, so they are included in the interval. So there's our domain and our range for this graph. For the second one, when we're looking at these arrows, it implies that it keeps going on forever. So this keeps extending out this way forever and ever, and this way forever and ever. So we can imagine that the domain just keeps going and never stops. Well, that means we get all the x values, all the real numbers, and we know that all real numbers is -infinity to infinity, and infinities always need parentheses in interval notation. Now the range starts at 0, but then it keeps going up forever and ever, slowly but surely. And so our range starts at 0 and then goes up to infinity with a parenthesis. Okay, moving down to number 3 here. Our domain is from here all the way to here. That's -4 to 4. And we do touch at those values, so we'll put brackets. Our range goes from here all the way to here. And so our range goes from -2 all the way to +2. And then here we have a line, just to kind of crystallize everything we've been talking about with lines and functions and linear functions. we can see that as we go down the negatives, this, like the absolute value function here, which we'll talk about in more detail in a later chapter, this keeps going up and keeps going to the left, so this is going to continue on forever in this direction. And as we go to the right, it's going down forever, and it's going to continue to the right forever, slowly but surely. So our domain, once again, is negative infinity to infinity. And our range, if this is going to keep going bigger, and this side is going to keep getting smaller, also is negative infinity to infinity. So one of the reasons that linear functions are so studied is because they're very useful for measuring constant change of anything, and they're always functions, and their domain and range are the same set, which is going to be more important later on when we talk about functions and all the cool operations that we can do with functions. So this is a really short section. This is all there is to it. There's going to be some other domain and range questions that you'll work on in this section, but that's what it is being able to identify domain and range, specifically from graphs. Now there's going to be some trickier questions that they get into to really kind of push you to think about what the domain and what the range really means. But that is the end of chapter 3.